We want to solve quadratic equations using the quadratic formula. And here we have the quadratic formula. This one, for example, 3 is already start out where one side of the quadratic equation is equal to 0. So we have the quadratic expression on one side, 0 on the other, so we can go right into start substituting values in. So our A value is going to be equal to 1. The B value is equal to negative 34. And the C value is equal to 289. So now we can work on just substituting those values in. So in this case, we get x is equal to negative b. So negative, then we use the parentheses for negative 34. And then we'll say plus or minus. Then we have b squared again, which is going to be negative 34 minus 4 times a times c, which is 289. And then we can take the square root of that for our discriminant. And then we're going to have 2, and our a value in this case is going to be 1. So we have our values all substituted in, and now we can start simplifying. So x is equal to negative times negative is a positive, so that's 34, plus or minus negative 34 squared. I'll use my calculator for that one. And we get, oh, I forgot the square there. That should be squared. Negative 34 squared. So we get 1,156. And then we also have the negative 4 times 289. And that just happens to be negative 1,156. That's still under the square root. And then we have the 2 times 1, which in this case is 2. So when we go ahead and solve that one, we get x equals 34 plus or minus 1,156 minus 1,156. That's going to be the square root of 0 divided by 2. Well, the square root of 0 is 0, so the plus or minus in this case just drops out, and we are just left with x equals 34 divided by 2, which in this case is going to be equal to 17. So we can take a look. Should have had this written in already, but we have x squared minus 34x plus 289. And if we did it right, we should have a solution at 17. And there it is right there, 17, 0. We have the graph, and there's just one solution. And then we can illustrate the difference between the two. Here we have the parabola that comes down and just touches the x-axis. So that has one solution at 17. And here we have one solution at 11 and one solution at negative 3. Actually, all parabolas have two solutions. In this case, on the left, you can see that there's two distinct real solutions. On the right here, there's two solutions. This is actually called a double root. At 17 has a double root solution there.